In this section, we'll discuss common issues and complaints from water well owners. We'll also cover the solutions for all these problems in the next section. What is the most common complaint about? Production or the quantity of water produced from a well. When you can't get enough water from your well to meet your needs, it's a problem. Next is the quality of water produced, most noted by odors, taste, color, suspended sediment, hardness, etc. Bacteria issues are high on the list and are often related to your other water quality problems. Dissolved gases, such as carbon dioxide or methane, are much less common issues but can occur as well. You should know that no two wells are the same, including your well and your neighbor's. Are you not getting enough water from your well to meet your needs? Does your well run dry when you put a lot of demands on it? Then you have a problem with what we call your water well's yield. Your well's yield is the rate that your well will produce water, generally expressed in gallons per minute or gallons per day. So, if I have a well that yields 1 gallon per minute and there are 1,400 minutes in a day, then I should get 1,400 gallons of water a day, right? An average person uses about 75 gallons per day. A family of 4 would require about 300 gallons per day. So, 1,400 gallons per day should supply my average household just fine. However, the typical garden hose flows at a rate of about 5 gallons per minute. So my 1 gallon per minute well will give me enough water for an average day, but it can't keep up if I'm watering the garden, taking a shower, or using more than one tap in the house at any given time. I need a well that does about 5 to 10 gallons per minute, or more, to keep up with typical household demand. If your well goes dry when you're using it a lot, then you have a problem with your well's yield rate. Why does it go dry? There are lots of reasons. Here is something we hear a lot. My water well used to produce fine. The driller said I can get 15 gallons per minute. Now it goes dry when I use it a lot. Why? First, it's important to understand that the first day of your well's life, it will produce its best yield ever. Then that yield rate will decline over time. This is true of any well. This list shows the many potential causes of a well experiencing low yield problems. In alluvial aquifers, if you have a lot of sand and gravel, these have larger open pores for the water to flow through. Now, if you have a lot of fine silt and clays in your aquifer, those will fill in these nice open pore throats and slow your water flow or yield down. In this jar has nice coarse sand and gravel. You can see the water is flowing through it real easy when I tip it back and forth. If your well is built of this material, you should have a high yield rate. This jar has some sand in it, but it also has a lot of silt and clay. I can't see the space between the sand grains because it's filled with those finer particles. So if your well is built of this kind of material, you'll have lower yield rates. In your bedrock aquifers, the water must flow through much smaller pore spaces or fractures within the rock. Porous sandstones or highly fractured rocks will produce more water than tighter shale, limestone, or coal. This here is a piece of shale or claystone. It's made from clay that is hardened into rock. If I drop some water on here, it sets on top and doesn't soak into the rock, unless it finds a fracture to move through. Here's a piece of sandstone. You can't see it very well, but there are small pores in between here. If I drop some water on this, I can see it soaking into the sandstone, spreading out. There's pores in this rock, and the water will actually move through this rock. This here is a block of coal. Now it looks pretty tight when you first look at it, but there's lots of small perpendicular fractures going at different angles through the rock. So water may flow through those fractures if you have this in your well. Does your well go dry in the fall or winter? Then you are likely seeing seasonal fluctuations in the groundwater table from seasonal recharge. Spring melt and rain runoff recharges the aquifer, which then drops during the drier fall and winter months, possibly dropping below your well pump. This is more common in shallow alluvial stream valley wells than it is in a deeper bedrock well, but it can occur in both. Once we drill a hole in the ground, we have disturbed the natural environment, and we've introduced oxygen where it may have not been before. This can accelerate bacteria growth or cause minerals to deposit on your well system, resulting in the plugging and fouling of our well screens or pumps, as you see here in these photos. So your well driller said he meets the minimum construction requirements. Does that mean you have the best system installed for your well? Maybe yes, maybe no. There are lots of options for the driller, and many of the construction rules are vague in certain areas. This leaves open for drillers a wide variety of options in terms of the quality of the well they construct. Here are some common well screens that you might find in your water well. This one here is a stainless steel wire wrap screen. There's a stainless steel wire going continuously all around the casing. It's a very narrow, thin slot that filters out rocks and sand before it gets into your well. It has a real high flow capacity, and this is the highest quality screen you can put in your well. On this end, I have what's called mill slotted PVC. It's similar in that it has a lot of small slots, but they're cut into the PVC directly. They're not continuous, but they still have a high flow capacity because there's hundreds of them in this one length of PVC. In addition, this pipe has what we call flush threaded joints. The pipe screws together, has an O-ring seal, and it's a very strong joint. These are both manufactured well screens, and they're very high quality. This is an example of a homemade well screen. You can see here there's a large slot cut vertically in the pipe. This is just ordinary PVC pipe, and someone took a skill saw and just cut by hand a slot in the pipe. This slot is quite a bit larger than the slots in the other manufactured screen. It'll let larger particles in which could do damage to your pump or your well. Now that homemade well screen may last a long time before it gives you a problem in some wells, but not as long as the manufactured screen. There are lots of other quality decisions a driller can make. He can shortcut the cleaning of the borehole, called developing the well, which removes the debris left over from the drilling and also properly sets the filter pack around the well screen. He can make the hole a little too small for the well casing. The pump may be located too close to the bottom of the well where it pulls in sediment. So the lowest bidder may meet the minimum construction requirements, but the lifespan of the well could be compromised as a result. A cistern is a tank used for additional water storage. Here was a concrete tank, but this could have also been a septic tank since they can look similar. As you can see, it's not in great shape. There are two hatches set flush in the top with mastic sealing that has worn away. A vent pipe was completely deteriorated and broken with only a flower pot and a coffee can to cover it. Here's a look inside that vent pipe. There's lots of floating algae and bacteria growth in there. Clearly not suitable for human consumption. Yet this well can produce clean, safe water. It turns out that the concrete tank was a septic tank construction and it was being used as a cistern. The well was only 7 years old, but going cheap on the cistern first time resulted in a $9,000 repair job. In the next section, we'll talk about the solutions to fixing the issues we just discussed.